All right, so here we are to part two of today. We're going to talk about the histogram a little bit more, and then we're going to talk about measures of central tendency. So again, I can't stress enough, when you have data, the most important thing is to look at it first by a graph of some sort, and we'll talk about other graphs that are possible down the road, like a box plot and a cumulative frequency plot. There's a lot of other graphing options, but you look at the graph first, and based on the shape of the graph, it will dictate which measures of center and spread you will use to describe that particular set of data. So once we've graphed it, we want to look at it, especially a histogram or even a box plot. We can do this later. You want to talk about whether it's skewed or whether it's approximately normal. That matters. And I think we alluded to this earlier already, but a skewed graph is pulled to one side or the other, either direction. And the tail itself is the direction of the skewness, where approximately normal distribution is bell-shaped, it's symmetrical, it's unimodal. And sometimes these words are often used instead of the word normal. So if somebody says a symmetrical graph, a bell-shaped graph, they're all talking about the same thing. So visually, what do those look like? It's a good question. We should take a look at that. And trying to get my screen to move. There we go. All right, so these two are both skewed, and this one would be considered approximately normal. Now this one is actually, it's not exactly balanced, but it's very close to being balanced, and that's why the word approximately is important in there. And these are both skewed, and then the tail, this is your tail. It levels off over here like the tail on a dinosaur, gets smaller and smaller as it goes to the ground. So this tail is over here on the left side of the graph, so this would be skewed to the left. This one has a tail going down here to the right, so this would be skewed to the right. So being symmetrical versus being skewed has an impact on measures of central tendency, so that's why we want to keep those into consideration. Notice that on the two graphs we did earlier, this was your heights and this was the number of siblings. These are both skewed to the right. You can tell that because they're smaller bars pulled and stretched away from where the center of it appears to be. The center's here, and there's actually a big gap and a bar. So this could even eventually, when we talk about it, might be considered an outlier because it's outside of the pattern, considerably removed from the pattern of the rest of the data. So these would both be skewed to the right, which means that we had a few people that were, maybe one person, a couple people that were much taller than everybody else. And same here, there was a person or two that had way more siblings than everybody else. And again, that's pulled to the right side. So when we, this is the summary for group data. You can, this is the last couple things we've talked about. You can pause and read this over. It's just a kind of a list of everything we've talked about lately. And now we're going to move on to looking at central tendency. There are three measures of center, and that's all this means. Where tendency is where does the data tend to land in terms of a clustering in the middle type of idea. And there's three different things that you can do to measure it. You can measure it using the mean, the median, or the mode. You've probably heard of all three of these. You've probably calculated several of them, or a couple of them, if not all of them. And to be honest, it's the exact same thing, so it hasn't changed. The mean, probably the most commonly used one, is literally the arithmetic mean. This means you add up all your observations and divide by how many observations you have. This sum again just means add up each observation, divide by how many there were. This is the Greek letter mu, which represents the population mean. There's another symbol for the mean, and that is an X with a little bar over it. It's called X bar, and that represents the sample mean. So when we look at calculator output, it will have the X bar. It won't have this mu, because it's assuming it's a sample. And I think for IB, when they talked about the exam, if it gives you data on the exam, you're okay to assume it is the population itself. And in the calculation of the mean, it doesn't matter. They're the exact same calculation. But it does matter when we start talking about spread and dispersion. So, but for mean, you add them up and divide. Mode, we already alluded to that. That is the value that occurs the most often. It is important to know that you might have more than one mode. You might have two values that occur of equal frequency and more than everything else. So that'd be bimodal. At 3, it'd be trimodal, etc. So mode is the easiest to see on a bar or histogram. Mean, you got to crunch the numbers. And then median is the other one, and it is the middle value. So literally you put them in order, and the median is a location. It's identifying what number falls right in the center of all of the data values. So this is just a way to calculate the location of that. It doesn't give you the actual value of it. This just gives you the location. If you have an odd number of pieces of data, there is one that is right in the center, a single value in the middle. If you have an even number of data values, there are 2 values that are in the middle. There's not one single middle value. So that's why you would then have to average those 2 middle ones to find the actual median. The median is also known as the 50th percentile, meaning that half of the data is below that value and half of the data is above that value. And it's also sometimes referred to as the second quartile, and we'll do a lot more with quartiles down the road. So these are just kind of literally textbook definitions. You can pause and jot them down, or you can kind of just, might already know what they are, and then you're good to go. So just quickly to discuss a couple of other values of a position would be the percentiles, which we alluded to. The median is the 50th percentile, but if you get your test grades back from SAT or ACT, you're usually also given what percentile you happen to be. Like if you're in the 90th percentile for your test score, it doesn't mean you got 90% correct. It means your score is above 90% of the people who took the test. So that's what a percentile calculates, and we'll look at that more later. And we know the median is the second quartile, but you can, if I'm talking about a second quarter, that means I can break it into 4 quarters. So you would also have a first quartile, which would be the 25th percentile, the third quartile, which would be the 75th percentile, and we will look at those a little bit more down the road. Those are other measures of position besides the center of your data, and they're also important. So to do central tendency, we're going to, trust me, you're going to use your calculator to do it. And again, there's a small difference in how to do it between having individual pieces of data and group data. This data is our heights, and it's already in our calculator. So if we want to calculate the actual value of all of our numerical summaries, hopefully it's still in yours as well. So if it wasn't, you would again, just as a reminder, hit Stat Edit and put all your data in. Mine's already in there. So instead, I'm going to go back and hit Stat. And now we want to calculate some statistics. So we come over to Calculate. There's a ton of stuff we can do. We're just going to do one variable stats. That's what that stands for. So if I hit Enter, it asks where is your data and what is the frequency. So I have individual data. So I'm going to change, and mine's in list 1. And I do not have a frequency table. I just have a list of data. So I'm going to change that to a 1. Again, in a minute, when you do it in a second for the siblings, you're going to put your data list, which is where the actual values of the data fall, and the frequency list is indicating how many times each of those happen. But in this case, I put in the individual data values, so I don't have a frequency list. And I come down here and I have an error, so I have to go to my error. I guess I just clear that out and I don't put anything in there. These calculators. And I hit Calculate, and there's all my data. Now this little arrow means that I could scroll down and find other values. This is what I was alluding to. That's X bar. That means the average or the mean. These are things that are used to calculate the mean. We'll talk about these 2 later. N is referencing how many data values you have. There are 23 kids with heights. This is obviously the minimum value. The shortest person was 59. This is that quartile 1, which is 25th percentile. And then if you scroll down, you would be able to get the median and the other quartile and the max. Notice that the median of 65 and the mean of 66.4 are pretty close, but the mean is a little bit bigger than the median because of that skewness to the right. That really tall individual, or a couple of those tall individuals, pulled that center towards the tail a little bit. And we'll talk about why that's important in a minute. So here you go. You're going to pause the video. You're going to put this in a frequency list. Again, list 1 and 2, or like I don't want to change my list, so I could list 2 and 3. And you got to make sure you put both lists in that frequency. So pause it, do it, try to run one variable stats, see what you get. All right, here are the values I got. When I ran one variable stats, just over 2 siblings, and again, notice that the median and the mean are very close, but the mean is a little bit bigger, and the mean is again being pulled away from the actual middle towards the individuals who had a lot of siblings. So to decide which measure of center you would use, either the mean or the median, depends on the shape of your graph. That's why it's so important to look at the shape of your distribution first. If your distribution is skewed, doesn't matter which direction, you use the median because it's a better representation of where the middle is. If your data is symmetrical or approximately normal, then you use the mean as a measure of center. And if your data is symmetrical and normal looking, the mean and the median typically are about the same. And so you're going to use the mean, and that's because we're going to do something extra with those special distributions down the road. So skewed, go to the median. Symmetrical, use the mean. And so for our histogram on the number of siblings, you might have to look back or think back. Would you use the mean or the median? And think about that for literally a second. Oh, there's our graph. See how it's skewed to the right? Therefore, I would use the median to represent the middle. Alrighty, and this is the end of this video. And this is something you may want to pause the video and just kind of read. This indicates the advantages of the mode, the mean, the median, when they're advantages, disadvantages. Notice that the mean is affected by extreme values. That's why we don't use it when we have skewness. The median is not affected by extreme values, so you would have a more accurate representation of the middle. So if I go back one graph again, because I didn't really talk about the mode, but this is the mode right here. So the mode would be 9 people had values, siblings, basically in the 2 range. So a lot of you had 2 siblings, which makes sense because that's also the measure of center. So again, this is just some good information from a IB textbook indicating the kind of comparing and contrasting mean, median, and mode. This one you're going to see visually from your graph right away, and you're going to identify exactly where it is, and then you're going to look at the shape of the graph to determine whether you're going to use the mean or the median as the measure of center. Even though your calculator gives you both of these, you're going to use one to describe it, generally speaking. All right, more on stats later.